class type is known as upcasting. Upcasting done by system implicitly. Upcasting always valid. See, A, here B. A is a superclass. B is a subclass. You observe, A is a superclass, B is a subclass. A is a superclass, B is a subclass. What I given see? Assigning an object or object reference of subclass type to superclass type is known as upcasting. That means B class assigning to A class or A class assigning to B class. B class assigning to A class, like this. B class assigning to A class. So it is upcasting. So up, that is the reason upcasting. Okay, upcasting. Now here examples. First one, A OB equal to new B. Second one, B OB1 equal to new B. B OB1 equal to new B. A OB2 equal to OB1. If I write. I'll explain. See, assigning an object or object reference of subclass type to superclass type is known as upcasting. Now, B is a subclass, A is a superclass. B class object or B class reference, if you assign to A class, that concept is called upcasting. Okay, that concept is called upcasting. Examples. First one, what I given, see, A OB equal to new B. Second one, B OB1 equal to new B. Now, in first one, which class object created? B class. Which class reference created? B class object assigned to A class reference. So, it is valid or not valid? Valid. In B class object, A members are present or not present? Present. That's what valid. So it is called valid upcasting. Here, OB1. OB1 is the reference of which class? B class. Assigned to which class reference? A class. It is also upcasting. It is also valid upcasting. It is also valid upcasting. See, think yourself and give me answer. What's the difference between first example, second example? First example, second example, what's the difference? In first example, object assigned. Second example, object reference assigned. Okay. Here, P class object assigned to A class reference. Here, B class reference assigned to A class reference. So, here I given assigning an object or object reference of subclass type to superclass type is known as upcasting. So, B class object assigned to A class reference up. Here, B class reference assigned to A class reference. It is also up. So, this is upcasting. Now, upcasting done by system implicitly, automatically done. Upcasting always valid. In B class object, A members are present or not present? Present. That is the reason we can assign. That's what valid. Okay. This is upcasting. Upcasting very simple, but downcasting difficult. You have to concentrate. Okay. Now, is it clear? If we create B object, in B object, A members are present or not present? That's what we can assign. That's what we can assign. Valid. Okay. Now, next. Downcasting. You can give answer. What is downcasting? Assigning an object or object reference of superclass type to subclass type. Right. Assigning an object or object reference of superclass type to subclass type is known as downcasting. Assigning an object or object reference of superclass type to subclass type is known as downcasting. Assigning an object or object reference of superclass type to subclass type is known as downcasting. Here you observe, assigning an object or object reference of superclass type to subclass type is known as downcasting. Just reverse. Here upcasting done by system implicitly. Downcasting must be done by programmer explicitly. Note, downcasting must be done by programmer explicitly. Otherwise, compile time error occurs. Downcasting must be done by programmer explicitly. Otherwise, compile time error occurs. Downcasting always needs upcasting to get memory. Downcasting always needs upcasting to get memory. Now, this one will see. See, upcasting you studied, that is just reversed. superclass type to subclass type, downcasting. But we have to convert explicitly. System will not convert here. If it explicitly, if you write valid, otherwise compile time error. Downcasting always needs upcasting to get memory. Memory purpose is required. Is it over? No. Here, it is A class, it is B class, it is super class, it is subclass. Now what is downcasting? Superclass object or superclass reference if you assign to subclass, downcasting. Okay. Now don't write. I'll get time for writing. Listen. It is important. Listen. Now already you have seen upcasting examples. With that examples, you can give answer here. First one. Seeing the upcasting example, you can give answer. What do you write here? P OB equal to new A. Okay. Second one. A OB1 equal to new A. Next. B OB2 equal to OB1. Okay. Don't write. I'll get time for writing. Listen. Here. Which class object created? A class. Assigned to which class reference? It is down. A class reference assigned to B class. It did downcasting. Now, here, is there any explicit conversion? No. That is error. Okay. So it is invalid. It is invalid. Suppose here, what I'll do, see, A B OB equal to in the brackets B, new A. Third one. Fourth one. A OB equal to new A. B OB2 equal to in the brackets B OB1. Now, you already studied starting 56 conversions concept is studied, no? In the brackets like this we written data type. That is explicit type conversion. We are calling like a typecasting. Okay. Now, first one error, second one error, third one, fourth one explicitly I converted. But one more point is there. Downcasting always needs upcasting. Here upcasting not there. It is also error. It is also error. Okay. Now, first of all, in the four places, which class object created? Which class object? A class object created. A is superclass or subclass? Then memory allocated to only superclass members. Is there any B memory? B memory is not there. Even explicitly if we convert also no use. Explicitly if we convert also no use. Okay. Here forcibly we are converting, but it is not converted. There is no memory. There is no memory. Okay. Forcibly if we try to convert also, it is not possible to convert. Okay. See, few people, they'll sit in a classroom forcibly. Will they get to learn subject? Will they get subject? No. Forcibly if we sit also no use. Like that. Here also, forcibly if I convert also not possible. Okay. Here, A object, forcibly I am converting into P. But in the A object, P memory is not there. If it forcibly we convert also not possible. Okay. Now, here, what I'll do, see, fifth one. A OB1 equal to new B. B OB2 equal to OB1. Now you observe here in first line, which object created? B object. In that object, A members, B members, all are there. Assigned to OBA. It is upcasting or downcasting? It is upcasting. Here OB1 assigned to OB2. It is OB1 which type? A type. OB2 which type? B type. It is downcasting. But downcasting must be done by programmer explicitly, no? It is also not valid. Now, A, OB1 equal to new B. B, OB2 equal to B, OB1. It is valid. Now, according to 3 points, it is there. You observe. You observe in first line, which class object created? B class. Memory allocated to A class and B class. Assigned to which class? It is upcasting or downcasting? Upcasting. Upcasting done by system implicitly. Upcasting always valid. So this line is valid. So valid upcasting. Okay. This line also valid. Valid downcasting. Valid upcasting, valid downcasting. This line valid. This line valid. Valid upcasting. Here valid downcasting. Now, first upcasting. Subclass object assigned to superclass. It is upcasting. Upcasting done by system implicitly. Upcasting always valid. According to that, it is valid. Here, OB1 is a reference of A class assigned to B class. It is superclass reference assigned to subclass. It is downcasting. Downcasting must be done by programmer explicitly. Explicitly is there. For doing downcasting, first upcasting required. It is also is there. So it is valid. Think yourself and give answer. Why fifth one not valid? There is no explicit type conversion. Here, invalid downcasting. Because there is no explicit conversion. But this is valid upcasting. Why third and fourth not valid? There is no upcasting. That's what these all invalid. There is no upcasting. Invalid downcasting. Invalid downcasting. Say here invalid, here invalid. Invalid downcasting, invalid downcasting. Reason, there is no upcasting. Why first and second not valid? There is no upcasting. There is no explicit type conversion. Both are not there. It is invalid. It is also invalid. Invalid downcasting. Okay. It is also invalid downcasting. Say invalid downcasting, invalid downcasting. Once again, why fifth one not valid? There is no explicit type conversion. Why third and fourth not valid? There is no upcasting. Why first and second not valid? There is no upcasting. There is no explicit type conversion. So if you want to do downcasting, first of all, you need to check upcasting is there or not. If it is there, explicitly is there or not, you have to check. If it is there, valid. 2 points you have to check. Okay, right is all. Now your doubt is where we use these all. Okay, after exception handling topic, every day we'll use. I'll show you. Every day up record, down record. Okay. After exception handling, while developing application, every day required. Because still you are learning concepts only. Java application means after exception handling application. Up to that, not possible. Invalid downcasting, invalid downcasting. 5 places invalid. Only last one valid. First, you need to check upcasting is there or not. If it is there, again explicit is there or not. If it is there, valid. Upcasting should be there. Explicit type conversion should be there. Then only valid. Over. Now, is it clear? Understood? Here, why downcasting needs upcasting? Why downcasting needs upcasting? To get memory. Okay. For first, memory should be there. Memory is not there explicitly. If you convert, also no use. That is the reason downcasting requires upcasting. See, Here, P object created. A members present, B members present. Assigned to A. A memory reference will explicitly converted to B because already B memory also is there. That is the reason converted, then assigned. So if you want to do downcasting, first upcasting is there or not, you have to check. If it is there, explicitly you have to do, then only valid, otherwise not valid. Okay. In 6 examples, only last one valid. Remaining 5 not valid. 5th one is not valid because there is no explicit type conversion. 3rd and 4th not valid because there is no upcasting. 1st and 2nd not valid because there is no upcasting, there is no explicit type conversion. Got it? Now, whether you understood or not, I'll check it out. Okay, I'll ask some questions. Whether you understood or not, I'll check it out. Because if I ask understood or not, all will give understood only. That's what I'll check it out. Suppose A class, B class, C class, D class, E class, F class, G class. Okay, many like a hybrid or hierarchical, you can say many classes. Say A class, B class, C class, D class, E class, something F class, G class. Now my question, carefully listen and give answers. Okay, my question, carefully listen. D class object, I'll assign to A class reference. D class object, I'll assign to A class reference. Is it valid or not valid? Valid? Sure. This is which one? Upcasting or downcast? Upcasting. Okay, it is valid. Okay. Now, D class object, I'll assign to A class reference, I'll assign to E class with explicit type conversion. Once again I'll say, D class object, I'll assign to A class reference, I'll assign to E class with explicit type conversion. Valid or not valid? Once again, listen. My question, maybe confusion will be there for you. Okay. Now, D class object, I'll assign to A class reference. A class reference, I'll assign to E class reference with explicit type conversion. Valid or not valid? Valid or not valid? How many plans are valid? Just raise your hand. Next. How many plans are not valid? Those who given not valid, why it is not valid? Here, D object created. Memory allocated to D class, B class, A class. Is there any E memory? No. You observe? Not valid. What you are checking is up is there, down is there, explicit is there. Up is there, down is there, explicit is there. Valid. Like that you are giving answer. Memory you have to observe. If we create D object, memory allocated to D, B, A. Reverse also same possible. Other location not possible. See, for example, in this building you came up. From that building, can you go down? Not possible, no? Like that. Okay. So reverse also, you can assign to B, you can assign to D. Other not possible. Okay. Here, D class object created, memory allocated to D, B, A. Then how can you assign to E? There is no E memory. Explicitly also not possible. Okay. So same root possible, same root, memory purpose. Okay. So this is only best example. In this building you came up. From that building, can you go down? No. From this building only you have to go down. No other option. Okay, like that. So reverse like this only possible, but other way not possible. Okay. One more question. F class object created, F class object created, assigned to A class reference. F class object created, assigned to A class reference. A class reference assigned to C class reference. Valid or not valid? Once again, listen my question. F class object created, assigned to A class reference assigned to C class. Valid or not valid? Why it is not valid? I didn't say explicit conversion. Explicitly required, no? I didn't say explicit. No, not valid. If I do explicit, valid. F class object, if you create, memory allocated to F, C, A. Reverse possible, C possible, but explicit required. Then valid. Got it? No. It is theoretically. Now programmatically we'll see. Now programmatically we'll see. Because downcasting most important. Further, many places downcasting comes. After exception and before exception handling only it comes. Before exception handling only it will come. Further, every day upcasting, downcasting required. Every day required. Every application required. See. I'll write the code. Think yourself and give answer. This code snippet, will it compile or not compile? This code snippet, will it compile or not compiles? Every line you observe and you answer. Okay. This code snippet, will it compile or not compiles? Again, if you give answer compiles, not compiles, also I'll ask reason. Okay. Only yes or don't, no, don't select. With reason. I want with reason. If not compiles also, you have to give answer why. If compiles also, you have to give answer how. If compiles, how it will compile. If not compiles, why it will not compile. Also I'll ask. First select compiles or not compiles. Compiles. Not compiles. Compiles. Not compiles. Okay. Any other? Not compiles. Don't see majority also. Majority given wrong answers many times you have seen. Okay. Majority also wrong answers given. No. That's what don't depend on majority people answer. Whatever you know, that is give answer. How many people answer compiles? 1, 2, 3, 4, 5, 6. Only 6 members. 7, 8, 9. Only 9 members. Online students. Next, how many people answer not compiles? Majority people no answer. Majority people no answer. You observe? Majority not given answer. No answer I don't accept. I'll wait. If you want, I'll wait. But think and give answer. Every line you observe. I have given time for thinking, not for discussions. Example,
Recording
this is
in
one example.
progress.
Again, with explicit also one more example. B equal to A. Invalid downcasting. It is valid upcasting. That is invalid downcasting. This is valid upcasting. valid upcasting, invalid downcasting. So here A equal to new B, it is valid upcasting. This A assigned to B, invalid downcasting. It's an error. In this 13th line, error. Over. Can we solve this error? Yes. What we have to do? Here in the brackets P. Now it is valid. See, compilation valid. Okay. Write this line also. Okay, the only this line write separate. It is valid downcasting. Valid downcasting. It is called explicit type conversion. Explicit type conversion. So downcasting must be done by programmer explicitly. Otherwise, compile time error occurs. That's what we have to write like this. It is also polymorphism. A class like a B class, B class like a class, like that we are calling polymorphic. Okay. Up to here, polymorphism completed. Okay. Next, abstraction. Noda. Next principle, abstraction. Providing necessary information without including background details. Is called as an abstraction. Providing necessary information and hiding unnecessary information is called as an abstraction. Providing necessary information and hiding unnecessary information is called as an abstraction. Providing necessary information without including background details is called as an abstraction. Providing necessary information without including background details is called as an abstraction. Providing necessary information and hiding unnecessary information is called as an abstraction. Both are same. Here, without including background details, nothing but unnecessary information. Providing necessary information without including background details is called as an abstraction. Providing necessary information and hiding unnecessary information is called as an abstraction. Here, without including background details are unnecessary. That is only hiding unnecessary information. See, one general example. suppose you'll go to shopping mall, you'll buy one television. Suppose you'll buy one television. They'll give television, a remote, and some cables, and in that box, one booklet will be there, manual. Okay. In that, how to make a setup, that information will be there. Step 1, step 2, step 3, like that's how to make a setup. And also how to operate remote, how to change the settings. That information will be there, no? In a booklet. That information, is it necessary or not? Necessary. Nowadays, so many options will be there. Smart TV. Okay. Without that one, you cannot change the settings also. Okay. Maybe only changing the volume, changing the channel possible. But so many settings will be there, no? In television. Nowadays, that booklet also they are not giving. Just they'll give a link you can download from internet. That is happening, no? Mobile, that television model, if you enter, that remote specification, everything comes. That information is necessary or not? Necessary. Without that information, you cannot operate remote. You may operate only changing the channel, changing the volume, but there are so many settings will be there. All settings not possible, no? So that information they are providing, that is necessary. But unnecessary information they are not providing. See, for example, how signal is going TV to remote, remote to TV, that information are they providing? Even if they provide, will you understand? No, it is unnecessary. So how remote manufactured, how television manufactured, how communication is going on, these all information is unnecessary for us. Just we are going to operate remote. We are not going to manufacture remote, no? So necessary information they are providing. Unnecessary information they are hiding. That is called abstraction. If they give unnecessary information, that book is wasted. You'll throw in dustbin only. No use. Okay, if they give unnecessary information. Whatever required, that is provided. Whatever is not required, that is they are hiding. That is nothing but abstraction. Even for example, myself also doing abstraction. This core Java, 2 years also I can teach. Only core Java. 2 years also I can teach. If I teach, your time waste, main time waste. Because your target is you want to get a job in MNC. Whatever required to get a job, that information I'm providing. But unnecessary information I'm hiding. It is nothing but abstraction. Because 2 years if I teach, will you come? 2 years? It is time waste. Already BTech 4 years over. Okay. Again 2 years for core Java required? No. Suppose your target is you want to do research in Java. Then 2 years required. Your target is if you want to do research in Java, 2 years also not enough. You have to learn. Okay. But your target is not research, no? Your target is you want to get a job in MNC. That purpose, whatever subject required, that is I'm providing. Unnecessary information I'm hiding. That is nothing but abstraction. But in programming, where is abstraction? Right? To implement abstraction in Java programming, we need abstract class and interface. To implement abstraction in Java programming, we need abstract class and interface. To implement abstraction in Java programming, we need abstract class and interface. See, abstract class required, interface required. With that, we can implement abstraction. See, while teaching object-oriented programming, what are the general examples I have taken? That is only for understanding subject. These examples don't give an interview. Okay. These are all only for understanding subject. Say, for example, class and object. I compared with plan and building. While teaching is a relationship, has a relationship. Apple is a fruit, car is a vehicle, like that I have taken example. Okay. Like overloading, overriding, some other examples I given. These are all examples only for understanding subject. These examples don't give an interview. Okay. No one will consider. Even myself also I worked as an interviewer. Some thousands of people have taken interviews, but those all we won't consider. Technical answer only will consider. What is abstraction mean? This is only how to give answer. Okay. And what is class means? Class is a plan, object is a building. No one will accept. Okay. Class is a collection of variables and method. Object is an instance of class. Technical notes I given, no. That is only how to give answer. Okay. Technical answer only how to give. General example, no one will accept. Even myself also I didn't accept while taking interviews. I have taken some thousands of people. I have taken interviews. At last, I got a irritation to take interviews because of your answers only. Different answers they are giving in interview. Seeing answers only, I got irritation to take interviews. That type answers they are giving. Okay. So these all whatever I covered, general example only for understanding subject. If I take pure technical, all people may or may not understand. If I add some general concept, everyone will understand. That is the reason only. You take any object-oriented analysis and design book. So many examples written author. Author also why is taking examples? To understand. Easily you can understand with general example. Object OOAD book is there. So many examples about abstraction, inheritance, polymorphism, encapsulation. So many examples are given to understand. Okay. Like that, some general examples are taken. These examples don't give an interview. Now, if you want to implement abstraction, abstract class interface required. About these two, we'll see tomorrow. Tomorrow, abstract class I'll explain. Okay, we'll see continuation tomorrow. Online student, any doubts are there?